We left off here. Let's keep going for part 2 of section 3. And how would I determine an empirical formula if I was given percent composition data? So if we know that a compound is 25.9% nitrogen and 74.1% oxygen, how would I get the empirical formula? So the first thing I would do is assume a 100-gram sample. And that means if I have 25.9% nitrogen, that's going to be 25.9 grams of nitrogen. Same thing for the percent oxygen. Next, I would want to be able to find the moles of each element. So the conversion factor I would use would be the molar mass of each element. In this case, you notice that it's N and O, so we don't use any subscripts of 2. And so we would just use the straight molar mass. So to calculate the moles of each element, we would divide by the smallest number of moles once we have the moles of each element, and then you should have a whole number ratio. These subscripts then are the empirical formula for that compound. So in this case, the empirical formula is N2O5, and we are going to calculate this in class. So please, and this is the first Easter egg, ask me to calculate this with you in class. The second Easter egg is to remind me to calculate the percent composition data. So, checkpoint. You are doing an experiment to try to find the molecular formula of a compound. You discover the percent composition. Can you determine the molecular formula? And the answer is tricky. You can determine the empirical formula. This may or may not be the molecular formula. And you would need more data to make sure that this is the molecular formula, not just the empirical formula. So, how does the molecular formula of a compound compare to the empirical formula? Well, sometimes they're the same, and sometimes they're different. So, empirical formula would be something like CH, and it would be the same empirical formula for ethine and benzene. And methanol has a different empirical formula, but that is also its molecular formula. However, ethanoic acid is also a molecular formula. But if we look at it and we divide ethanoic acid by 2, its empirical formula would be C1H2O1, which has the same empirical formula as glucose. So sometimes they're the same and sometimes they're different. So, more of that same sort of thing, and so etc. So, methanol, which is formaldehyde, has an empirical formula that's CH2O. This is the same empirical formula as ethanoic acid and glucose. And so they are very different chemicals. You can eat ethanoic acid, which is vinegar, acetic acid. You can eat glucose, it's fine. But methanol or formaldehyde, you don't want to eat. It would actually kill you. So the molecular formula of a compound is either the same as its experimentally determined empirical formula, or it is a simple whole number ratio or multiple of that empirical formula. We're almost done. Once you've determined the empirical formula of a compound, you can determine its molecular formula if you have the compound's molar mass. You can calculate the empirical formula mass. I abbreviate this EFM of a compound from its empirical formula, and then you could compare it to the molar mass, and you would divide the molar mass for the compound divided by the molar mass for the empirical formula, and that number is what you would multiply through the formula by to get the molecular formula. So, this quotient gives you the empirical formula units that you would have to multiply by, and you would get a multiple of that empirical formula. Finding the molecular formula of a compound. Calculate the molecular formula of a compound whose molar mass is 60.0 grams and the empirical formula is CH4N. Your first step would be to multiply hydrogen by 4 plus carbon plus nitrogen. Once you get that answer, you would take 60 and divide it by that answer, and that will tell you if it's the same or different. If you get 1, the empirical and molecular formulas are the same. If you get a whole number, then you would have to multiply the empirical formula subscripts through by that number. So you'd find the empirical mass of the formula, and you probably want to stop and write all this down. Find the empirical formula mass, and divide the molar mass by the empirical formula mass, round to a whole number. So if it's 4.99, that's essentially 5. If it's 1.99, that's essentially 2. And you would multiply the subscripts by that whole number to get a molecular formula. So, what information in addition to empirical formula is necessary to determine the molecular formula of a compound? You would need to know the mass of the compound, molar mass of the compound, and you'd have to calculate the empirical formula mass. So, key concepts. Percentage by mass of an element is the same. We do any other percent, the part divided by the whole. We do this in mass, so in grams, and then multiply by 100. And you use the molar masses for each element off the periodic table. Percent composition of a compound can be used to calculate the empirical formula of that compound. The molecular formula of a compound is either the same as its experimentally determined formula, or it is a simple whole number ratio, multiple of that formula. And there's a couple of calculations you need to be able to do from this section. So percent composition, empirical formula are 2 of your glossary terms. The big idea is that molecular formula of a compound can be determined by first finding the percent composition of the compound and determining its empirical formula. Using the empirical formula mass and the molar mass of the compound, it is possible to calculate the molecular formula. And the end. Woohoo! We are done. Thanks for listening.